Light, the mystery we see with. We see the world around us because of light. Light is the invisible artist painting our surroundings with colors and shapes. It bounces off objects and enters our eyes, allowing us to perceive the beauty and complexity of our environment. Our eyes then send signals to our brain and our brain creates images. This process happens so quickly and seamlessly that we often take it for granted. But have you ever stopped to think about what light actually is? It's a fascinating phenomenon that has puzzled scientists and philosophers for centuries. It's quite strange when you think about it. We see because of something we can't actually see itself. Light is both mysterious and essential. Light is a form of energy that travels in waves. These waves are part of the electromagnetic spectrum, which includes everything from radio waves to gamma rays. These waves are very, very small. In fact, they're so small that we can't see them individually with the naked eye. What we see as light is actually a huge number of these tiny waves all traveling together. They combine to create the light we experience every day. Imagine a vast ocean with waves constantly moving. We don't see each individual water molecule, we see the wave as a whole. Light is similar. It's a collective dance of countless tiny waves, creating the vibrant and dynamic world we see. So next time you marvel at a sunset or gaze at the stars, remember the incredible journey of light that makes it all possible. So if light is made of waves, why can't we see them? It's a question that has puzzled many for centuries. It all comes down to how our eyes work. Our eyes are incredible organs, but they have their limitations. Our eyes are designed to detect a very specific range of light waves. This range is known as the visible spectrum. These are the waves that we see as colors, from red to violet. Each color corresponds to a different wavelength of light. This range of visible light is actually just a tiny sliver of all the different types of light waves that exist. Beyond what we can see, there are ultraviolet rays, infrared waves, and even X-rays. Light travels incredibly fast, much faster than anything else in the universe. It's hard to even comprehend such speed. It zips along at approximately 300,000 kilometers per second. To put that in perspective, it means light can travel from the sun to the earth in just about 8 minutes. That means it could circle the earth over 7 times in just 1 second. This incredible speed is what makes light so fascinating. This speed is why we see things almost instantly when they happen. Whether it's a lightning strike or a shooting star, light brings the universe to our eyes in real time. It's also why we see stars that are incredibly far away. Their light has been traveling through space for a very long time to reach us. Some of the stars we see at night are so far away that their light has taken millions of years to get here. Beyond the colors we see lies a whole hidden world of light. This is what we call the electromagnetic spectrum. This spectrum includes all the different types of light, arranged according to their wavelengths. At one end of the spectrum we have radio waves, which have the longest wavelengths. These are followed by microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and finally, gamma rays with the shortest wavelengths. Each type of light on the electromagnetic spectrum has unique properties and uses. Radio waves are used for communication, microwaves for heating food, infrared for night vision, ultraviolet for sterilizing, X-rays for medical imaging, and gamma rays for treating cancer. So even though we can't see most of the electromagnetic spectrum, it's all around us, playing a vital role in our lives. Section 4. Seeing the unseen tools for detecting light. While we can't see most of the electromagnetic spectrum with our naked eyes, scientists have developed ingenious tools and experiments to detect and study these invisible forms of light. These tools allow us to explore realms of the universe that would otherwise remain hidden from our view. Radio telescopes, for instance, capture radio waves from distant galaxies, allowing us to map the universe and understand its origins. These massive structures are often located in remote areas to avoid interference from human-made radio signals. Infrared cameras can see the heat signatures of objects even in complete darkness, which is useful for everything from firefighting to wildlife research. Firefighters use them to locate people trapped in smoke-filled buildings, while biologists use them to study nocturnal animals without disturbing their natural behavior. One simple experiment you can try at home to see the invisible is to use a prism. This small, transparent object can reveal the hidden spectrum of light that surrounds us every day. When light passes through a prism, it gets split into its different wavelengths, revealing the colors of the rainbow. This phenomenon is known as dispersion, and it beautifully demonstrates the complexity of light. This is because different wavelengths of light bend at slightly different angles when they pass through the prism. Shorter wavelengths, like blue and violet, bend more than longer wavelengths, like red and orange. This experiment shows us that white light is actually a mixture of all the colors of the rainbow. By using simple tools like prisms, we can uncover the hidden beauty and complexity of the light that illuminates our world. Section 5. Light's invisible hand in our world. Light, Even the parts we can't see plays a fundamental role in our universe. It's the primary source of energy for life on Earth through photosynthesis. It allows us to communicate across vast distances through fiber optic cables and satellites. It helps us explore the universe and understand its mysteries. So the next time you switch on a light bulb, remember that you're not just illuminating a room, you're interacting with a fundamental force of nature. It's a force that's both invisible and omnipresent, shaping our world in countless ways that we're only beginning to understand.